Yeah. Hello, everyone. My name is Prasenjit, and we are the team Relocation Navigator, one insightful guide for moving within the United States. Yeah, so the agenda for today's presentation is we will start with the introduction, like what, why, and how of this project. Then we'll speak about what problems we are trying to solve during this project. Then we'll briefly speak about the technical tools which we use. We will speak about the system architecture which we build. We will speak about the back end, front end, the data tools which we use during this process, during this project. Then we'll speak about the data modeling, its analysis, and what were the learning for us from the data. Then and at the end, we'll show the demo, like how our dashboard is working, how interactive it is, and what problems it can solve. So yeah, that is the agenda. So yeah, let's speak about the introduction of this project. Like, what is the project? So we try to build a unified dashboard for comprehensive relocation insights. So what I mean by that is, like, I'm a student, and most of us are the students, and we are looking for the jobs, and it is more highly likely that we will relocate to the new place. So we want to give that confidence to the students or the people who are going to relocate that they are making the right call, they are making the right decision. So we want to help them take that right decision. So yeah, that's why we are trying to build this one unified dashboard for comprehensive relocation insights. So it will give a detailed information, something relevant to the housing prices, safety, demographics in the United States. So when we are relocating to the new place, we look at, like, I'm getting particular salary. On that basis, is it the housing prices affordable at that new location? Okay, the affordability is done, a done deal, then is it safe to live in that particular area? What the record tells us, like how much are the violent crime? How much is the crimes against women over there? How much are the different kinds of crimes over there? So overall, how is going to be my safety in that particular location? And then demographics in that particular United States of the region, United States, into that particular region. Yeah. So it will help to make it easy to compare. Maybe if we have like options, like I have an option like moving into San Francisco or maybe San Jose, and I have to make a one call out of these two cities, or I have an option to choose between two states, maybe Texas and Florida, and I have to take a call between what would be the best one for us. So this dashboard will help, and which will help to take that right decision. So it will basically it will help you to get a data-driven analysis relevant to the relocation process. So yeah, that was the what of the project. So why? Why of this project is basically we wanted to simplify the complex relocation decisions for job seekers and students. We want to empower the users with data on safety and cost of living, and overall take help them take informed decision about it. So this was the target, and this was the aim of this project. Now, how we built it, like how we built this dashboard. So we utilize the data from the Atom API. So whatever the real estate data we wanted, we used Atom API to extract that data. So we were having the information like what is the price of that particular house, where is it located, where it is exactly located, like what is the zip code for it, what is the longitude and longitude for that. Uh, what is the market price? What was the market price 10 years back? What is it now? How big is the house? So, for example, in certain region, how big are the in general houses are? Like, what is the square feet area of the hall, maybe the living room, maybe the bedroom? Do they have the amenities like swimming pool, maybe parking lot, and all this kind of details we tried to extract it from the Atom API. Then we wanted to understand what is the crime rate over there? What is the status about regarding the violent crimes in that particular area, maybe in the particular state or at particular zip code? So we use this public platform called as USA Facts to get that data. So we tried to get the data like what records tells us, and we have the record from year 1979 till the year 2020. So we got this data like for 100,000 person living in that particular zip code, what is the crime rate? Like how many people were faced the charge, faced the were being assaulted or had some records of the criminal activity. So yeah, we got the criminal data using USFI, and using this data, we built one dashboard which was interactive. You just need to hover a few of the maps, and you will get to know what are the data showing in that particular area. So yeah, so yeah, what problems we are trying to solve over here, or basically what questions we are trying to answer in during this project is like, what is the current state of the real estate market dynamics? What it was yesterday, what it is today, and what maybe it likely to be in tomorrow. Then, how is the neighborhood safety in particular location? Which one is better? If you have two options, as I said, maybe Texas or Florida, we can give an easy comparative analysis for making a better decisions. Then which is the optimal choice? People have some choices, some preferences. So managing those and helping them take the optimal, take a right call on their optimal choices. And so basically, overall, we wanted to streamline this relocation research process and help the users to take the right decision about their relocation. So yeah, now let's get into the technical details.
So hi all, I'm Divyani. I would be continuing from where Jeet left. I would be first covering the architecture, which essentially implements extract, transform, and load. Our project is hosted on Google Cloud Platform, and data has been extracted using from a Atom API. The data was collected using Python and stored in the landing bucket. The data was extracted according to zip codes and hence was then merged and stored in the merge bucket. And after undergoing cleaning and transformation processes, we finally merged it with a pre-cleaned FBI crime data, seamlessly integrated with our dataset in BigQuery. Then we leveraged Tableau for analysis and visualization, coupled with Apache Airflow orchestrated in Docker for streamlined workflow automation. Streamlit was used to construct a recommendation system and was also connected with Tableau to form our final product, a website relocation navigator. Next.
Hello all, my name is Santosh. So I'm mainly focused on data collection and cleaning part. So in the first stage, we focused on data extraction. Here we employed some Python scripts to interface with various APIs and Google Cloud services. The goal is to gather a vast amount of real estate data. The step is crucial as it sets up the stage for everything that follows. We are here using the zip codes to extract the data from the Atom API. We ensure that our data extraction is more comprehensive and selective, targeting the most relevant and rich data sources. Our approach respects API rate limits and ensures data integrity, which is a fundamental for the reliability of our entire process. Next. So in the merging data, when we are talking about the merging data, so we collected all the raw data in our and that's our challenge to collect all the raw data and to create a unified data set from the disparate from this disparate information. This is where our data merging process comes into play. We merge the data from multiple pairs of API responses and various formulas into a single coherent data. I mean, for each zip code, we are having some multiple data, multiple CSV files. So we merged based on the zip codes, we merged each and every CSV file into a single zip code. So each piece of data, no matter how small, is crucial, and our scripts ensure that they are fit together seamlessly. The result is a comprehensive data set that serves as a single source of truth for all subsequent analysis. Next. So in the data cleaning, we mainly focused on data cleaning. I mean, we have some critical for ensuring the quality and usability of our data. Here we tackle the common challenges of raw data, like inconsistencies, missing values, and irrelevant information. Our script methodology clean and refine the data set, removing unnecessary columns, filling in missing values with mode and mean imputation strategies, and correcting data inconsistencies. This stage transforms our raw data into reliable and accurate resource ready for in-depth analysis. It's a meticulous process, but it's what makes our data truly valuable.
Thank you, Santosh. Before covering the data transformation, I would like to talk about data modeling. For data modeling, we chose the model of 3NF, which stands for third normal form, which is a database normalization level that ensures data integrity by eliminating transitive dependencies. So here you can see that we have six tables, and our primary table is the property data. Uh, so this primary key of the property data is then connected with all the other tables as a foreign key. So we would be implementing this model into our transformation step. The data processing workflow began with the ingestion of information from the merge bucket, encapsulating it within a pandas data frame labeled TF. Ensuring the integrity of related data sets, duplicates were meticulously eliminated from the property data frame. A, a pivotal entity serving dual roles as a primary key and a foreign key. In preparation for future integration with BigQuery, thoughtful adjustments were applied to the data types of certain columns, with a specific focus on aligning date formats. This meticulous attention to detail aimed to guarantee the seamless compatibility of the dataset with the corresponding columns in BigQuery. The culmination of these steps led to the creation of a refined dataset, strategically crafted for optimal synergy with BigQuery's architecture. So after the data transformation from the transform bucket, we loaded the data to the BigQuery. So I would hand over to Amit to cover the demo.
Hey everyone. Uh, I'll just give like a brief demo on what we have worked on. So this is how our relocation navigator DAG looks like overall. Uh, so we have these multiple nodes here, if you can see, and this particular Airflow is actually running on Docker, and we have like a YAML file which we have edited based on our needs. And we have mounted this particular folder called scripts to the Airflow containers, where once we drop all the relevant files that we require in our DAG, it will be available for all the containers in the Airflow. Now, if you go to the DAG code, it looks something like this. So our DAG has like multiple nodes, and if you see the very first node, this is basically like calling the API and then extracting the data from API based on the zip code and writing it to our landing bucket. And then, so we are doing it for like multiple zip codes, and we'll be having like huge number of files that are being piled up in our landing zone. So now what our second node will basically do is this will pick up the data from the landing bucket, and then it will merge the data based on the zip codes and write it to merged bucket. So our our buckets look something like this. Uh, so as I was mentioning earlier, this is how we extracted all the data from the API based on zip codes. So each zip code has different page numbers. So like this, we have like huge number of files in our landing bucket. And if you see our merge bucket, which I was mentioning earlier, so the data that was there in the landing zone, we are reading it and then merging all the similar zip codes into one single file. So that is how we'll have like one single zip code file in our merge bucket. Now, if we go back to our DAG, the next node is clean data node. So what this basically is doing is reading the entire data from the merge bucket and then performing various mean mode imputations and stuff, and then cleaning our data. And then we are writing our clean data to the to another bucket, which is nothing but our staging bucket. So if you see, this will have like clean data.csv. So this will have uh, all the zip code information in it piled up into one single file. And then once this is done, we have another node, which is basically like transforming all the data that we have in the clean. It is reading from the clean data and then transforming the entire data based on the six tables that we have that we got from 3NF form. And then we are writing those 6 different files to our final bucket, which is nothing but our transformed bucket. So this is our transformed data bucket, and if you can see, we have 6 different files for 6 different tables, apart from the file that we generated from the FBI website for crimes. So all this data is then being transformed and then sent to our BigQuery, which is nothing but here. If you can see, we have like 7 different tables, and this is happening at the backend in the DAG using operator called GCS to BigQuery operator. So this is basically like reading the data from our GCS bucket in the transform data and then creating a BigQuery table out of it directly. So our nodes look something like this. So we have like 7 different nodes for 7 different tables. And once this is done, our process ends. So this is how our process looks end to end, and we are using Airflow to orchestrate our process. Now let us continue with our dashboard part. So let us go to Tableau.
Okay, so you can discover your ideal relocation place effortlessly with our relocation navigator dashboard. Easily compare states based on price indices, safety levels with crime rates, and tax structures. Gain insights and make informed decisions that align with your preferences and budget. So your journey to finding a perfect place starts here. So we'll just dive into the first dashboard. So here is the dashboard which focuses on sale amount for different aspects. The map on right paints a vibrant picture of the average house sale amounts, and you can just hover on these graphs to get detailed information. Can you just do that? Can you just hover on those on the map? Yeah, so it gives a detailed information, providing the state name and the average amount per state. See, so the other graph dives into the trends of sale amount over the years, revealing a subtle upward trajectory in upward sale prices despite occasional fluctuations. Yeah, and this is all these graphs are interactive, and I'll talk about this later. And the third graph which we plotted was it breaks down the sale amounts based on the heating types. So as Howard, so can you just hover on one single thing, Amit? So to see the particular heating type of, if it's gas heating type, then the average sale amount is around $334,000, with highest being the package heating type. So the interesting thing is, I mean, you can select a specific point and other graphs instantly adjust to provide a comprehensive view of that specific topic. Yeah, that's what it does. You can just select a specific thing that you're interested in, and it just narrows down the topic and shows information based on that. Okay, so we'll move on to the next sheet. So as I pointed out in the beginning, that price, crime rate, and tax structure are important factors for relocation. So here is the visual graph of average crime rates for different states. So you can observe that California has the highest crime rate, followed by Texas, whereas North Dakota has the least crime rate with 959, which is just on the top near the Canada border. Uh, yeah, that's fine. Okay, we'll move on to the next sheet. Okay, so here is the tax efficiency graph, highlighting states with lower taxes. So here you can see which taxes, which states have lower taxes, and also you have a filter on the right with named with state. So you can just select the state that you're interested in, and you can just click the checkbox, and the state appears in the dashboard. So Amit, can you just click on the Washington, which is unchecked? So we'll just see it in the graph. Build shop. Yeah. So there it is. You can just select the state that you're interested in, and you can see the average tax amount for that states, and you can decide based on that. Okay, we'll move on to the next sheet. This is just the tax amount over the years, and if you look at the graph, right, we have two huge spikes, one in the year 2012 and one during the COVID time, that was during 2020 and 2021. So in these two periods, we observed huge spikes for the tax amount. So yeah, so using this interactive dashboard, I mean, we can gain insights and make decisions accordingly in choosing the place. Okay, now Devyani will walk you through the relocation recommendation system.
Thank you, Vineet, for great insights. Welcome to Relocation Navigator, our product. This is deployed on Streamlit. As you can see, it's still under construction. So let's explore the recommendation page. This is a very basic recommendation system. And let's set our price range as ceiling, because why not? So yeah, let's have the number of bedroom as 2, and let's go to main, because why not? As you can see, these are our recommendations. So here I can see the sale amount, and I can of course compare the prices, and I can see when the sale was recorded and if it's a resale or not. I know that many of you think that this app is faulty. Why not try for another state and change our price ranges? So according to Vineet, the tax is very low in Kansas. So let's explore Kansas. So as you can see that the tax is low, but The sale amount is, I think, pretty much fine for a 2 bedroom. So yeah, this is a very basic recommendation system. So coming to future work, of course, we will work further on our Streamlit app, and we will try to implement recommendation system using deep learning and hence leveraging MLOps. And for we can try to use streaming service to fetch real-time data. You can also read through these references. This is about pattern data and the client data. And thank you so much.